To Unit 2. I will tell you, Unit 2 is all about the math. So we are going to learn all about the math that you will need in order to be successful in chemistry. So we are starting out lesson 2.1 with significant figures. We're going to talk about what they are, how to find them, and just some other information about significant figures. So first, it is really important for scientists when they are recording data, when they are doing experiments, that they keep track of what numbers are important. There are some numbers that are important and some numbers that are not as important. And it all has to do with the instruments that they're using to take the measurements, the balances for weighing, the rulers for measuring, and all the other sorts of instruments that they're using will determine what numbers are important and what numbers are not important. So first off here, we're going to go over the rules to figure out how many significant figures are in measurements that scientists do. There are some very specific rules. That is so that all scientists around the world will do everything the exact same way. So their results then will be shareable between different countries and different scientists. So first rule, numbers that don't have decimal points. So if there is no decimal point in your number, start at the right and ignore all of these zeros till you get to a non-zero number. And then you count all of the digits to the left of those zeros. Okay? So, like for this example, all of these zeros are not significant. And we start counting here. 1, 2, 3. So there are 3 significant figures in this number right here. With this example, again, we start at the right. All of these zeros are not significant. And we start counting here. 1, 2, 3, 4, 5. There are 5 significant figures in this number. You might be tempted to skip this zero. Don't skip this zero. It is significant because it is in between 2 non-zero numbers. Okay? The only ones that are insignificant are the ones that are to the left. Rule number 2. Now, if we have a decimal point in our number, what we do is we do basically the opposite. We start at the left and ignore the zeros until we reach a non-zero number. And we count the numbers to the right of those zeros. So if there's a decimal point, we start here, skip all these zeros, and then we start counting. 1, 2, 3, 4. So this number here has 4 significant figures. Now with this number, we start at the left because there's a decimal point, skip that zero, but this is a 1, so we're going to start counting. 1, 2, 3, 4, 5, 6, 7. You can see here, there's 7 significant figures. We count the zeros because they're in between, and because there's a decimal point, this one counts 2. So we're kind of going the opposite direction in rule number 2. All right. So here's another thing about decimal points. Remember we talked up here how there was no decimal point. Well, sometimes those zeros at the end of a number are important. And scientists need to say, hey, those zeros are important. Don't skip them like you did up here. The way that they do that is they put a decimal point at the end of the number, or sometimes, and very less common, they'll put a bar over the top. But this decimal point is the most common. That means this zero, count it. It is significant. I put that decimal point there to tell you that. So this number, 1, 2, 3, 4, 5 significant figures. And this number with the bar over it, 1, 2, 3. So those designations mean, hey, these zeros actually are important. The third rule here is if we have exact counting numbers. Like if I were to count the number of people in the room, Or if we were to count the number of atoms, like in some examples here, coffee cups, phones, whatever, it's exactly that we're counting and not something that we measured, like with a ruler or a balance, then all the numbers are significant. It does not matter. So if we're counting something, every number counts. Every number is important. So here, like we're counting atoms, that's a distinct number we can count. 1, 2, 3. There's 3 significant figures. And same here with cups, 20,000 cups. Even though those are zeros, because we're counting something specific, those numbers are significant. So 1, 2, 3, 4, 5. There are 5 significant figures there. Rule number 4 here, if we are using scientific notation, which we will talk about in much more detail in lesson 2.2, but you should have, with your math, had a little bit of scientific notation. Excuse me. Oh my gosh, I'm so sorry about that. But when you're converting a number to scientific notation, you only use the significant numbers. I'm going to abbreviate numbers because I can. So if you have something in scientific notation, all of the numbers are significant. Okay. So again, we'll go over this in more detail in the next section. But scientific notation. We start here and count the number of places to move the decimal. 1, 2, 3, 4, 5, 6. So this is 7.051 times 10 to the 6th. You don't quite understand that yet. We're getting there. Which means this number has 4 significant figures. I'm going to abbreviate it. And here, move the decimal point 1, 2, 3 spaces. So this is 9.7023 times 10 to the negative 3. And its number of significant figures is, can you see my decimal point? It's 1, 2, 3, 4, 5. 5 significant figures. All right. So let's see. Let's do some calculations really quick with these scientific or significant figures. Sorry. There are rules with how to do calculations with significant figures too. It's very important that we stick with the rules. So there are rules in how to write your final answer. Super important. Okay. That way we're keeping track of the number, the correct amount of significant figures. Oh, you guys. Sorry. I'm going to abbreviate that too. You'll see it abbreviated sometimes as sig, fig. Okay, so we're keeping track while we're adding and subtracting. Okay, so with addition, the answer is written with the same number of decimal places as the least precise measurement in the calculation. So, same number of decimal places as the least precise. So you see this number has 3 places past the decimal. This number has 1. This number has 2. So the one with the least amount of spaces past the decimal is that one. So when we do our addition, and we come up with 15.990 centimeters, in order to write that number with the correct number of significant figures, we can only have 1 place past the decimal, because that's what this number has. Okay? You've heard that saying that the chain is only as strong as its weakest link, right? Well, calculation is only as strong as its weakest number. So our number can only be as strong as its weakest number, which means we can only go to 1 place past the decimal. We round, blah, blah, blah. We get 16.0 centimeters. 1 number past the decimal, because 1 number past the decimal. Okay, so that's addition and subtraction. With multiplication and division, the answer is written with the same number of significant figures. I'm going to abbreviate that again. As the number in the least precise measurement. So now we're looking at all the numbers. We don't care if they're before the decimal or after the decimal. So if we look at this calculation, we have 8.1 kilograms times 9.806665 meters per second, which is the speed of light, if you didn't know that. Anyway, so this number has two significant figures. This one has 1, 2, 3, 4, 5, 6. So our answer needs to have two significant figures. Right? So we multiply those two numbers together, we actually get 74.43385. Add in my units, kilograms times meters per second. Okay. But in order for this answer to be correct, and anytime you guys do quizzes or anything from now on, this will apply. In order for this answer to be correct, it's got to have the correct number of significant figures, which is 2. So I got to round my answer so it only has two significant figures. Y'all, I hope you're doing your math with me, because it's actually 79, not 74. I hope you're at home yelling that I did the math wrong. Anyway, so two significant figures. So my answer, 79 kilograms times meters per second. Rounded to two significant figures, because this number has two significant figures. Okay? At adding and subtracting, places past the decimal. Multiplying and dividing, total significant figures. Right, those are the two rules. Okay? Pause the video right here, answer these practice problems, and I'll create another video that answers them for you. So I guess the video is going to end. But answer these, and then you can watch the video that shows the answers.